The C BOA tool calculates the estimated financial impact of energy savings related to measures. To do this, it uses the utility rate information input by the user on this worksheet, the gas rate worksheet, and the next two worksheets, the electricity rate and demand worksheets. This tutorial will discuss these three worksheets. Note that the information that's input on these three worksheets affects the cost savings of the measures, not the annual kWh, kW, and therm savings. On both the gas rate and the electricity rate worksheets, you enter the begin and end dates for the summer periods, and the tool automatically populates the winter periods on the right. Utilities sometimes have different rates for summer and winter periods, and the tool can account for these differences. For our project, the gas rate is the same for summer and winter, so we don't need to adjust the dates. If you have questions about any of the inputs or how they are used, the tool includes comment boxes, such as the one that's shown here, and also an extensive help menu that can help. And for the help menu, you click on the question mark and it will show you the help screen. On the gas rate worksheet, you enter the cost per therm for each period. So let's go ahead and do that for our example project at 95 cents a therm. Note that these rates should be the incremental rates, which are the rates paid by the customer for the last therm consumed, not the average rate. The incremental rate is often different from the average rate for tariffs where the rate varies by the amount consumed. For example, if the gas rate decreases with increasing consumption, then the incremental rate will be less than the average rate. Since the focus of the tool is on savings, not baseline usage, entering the incremental rate will give more accurate dollar savings estimates. Once the summer period has been defined and the rates have been entered, you can add a name and save the file for use on another project. So let's do this here as an example. We'll call it gas rate 1, and we can save it. And just save it over to the desktop. And what I'll do here is I'll just change this to $1 for this one here so that you can see the new rate when it comes in. We can bring in that rate that we just saved, called gas rate 1, and you'll see that it returns back to the value we had before. This may be useful if you work on another project in the same utility area. On the electricity rate worksheet, up to 6 time of use periods and rates can be entered, corresponding to peak, mid-peak, and off-peak for both summer and winter periods. This is consistent with common commercial rate structures for California's utilities. Tariffs with more than 6 time of use rates or tariffs that include more complex tariff structures such as demand ratcheting may require additional analysis outside of the tool. Note that the rate creator does not assume that weekends and holidays are charged off-peak rates. Therefore, in a situation where the building operates on the weekends, you would first run the tool with the building's weekday schedule and define the rate structure for those days, and then run the tool again for the weekend schedule with the weekend rates. This would then require additional work outside of the tool to sum the savings. Future versions of this tool may account for weekday and weekend variations. First, let's enter the summer beginning and end periods. And for our example project, we're going to say that the beginning period is June 1st and it goes through September 30th. Then we can enter the utility rates for each time of use period. So for our summer peak, we are going to be at 13.5 cents. Mid-peak is this amount. Off-peak is 6.6 cents. And then for winter, we'll enter those rates as well. This is just for our example project. Similar to the gas rates, the time of use rates should be the incremental rates, not the average rates. In other words, the rate of the last kilowatt hour consumed. Then what we do is define the specific time of use periods. I'm going to zoom out so we could fit it all. The grayed out hours on these charts, tables, represent the times corresponding to the rate period. Let's show how to do this for an example project. First, what we'll do is click the first cell of the summer peak period, Then drag the mouse through each hour in the period. So this would be peak from 12 through 5 o'clock. For our project, the summer TOU period is from 12 to 6 p.m., so we'd select the 6 cells, or hours, starting at 12 p.m. Note that the last cell we select is 5 p.m., meaning that the time of use period lasts through 5 p.m. and does not go through 6 p.m. Then we hold down the control key and select the mid-peak periods. Let's go ahead and do this. And remember to hold down the control key from this point on for the summer periods. And then still holding down the control key, we select the off-peak periods with no overlap of hours. Next, we can unhold the control key and click Set at the bottom here. Note that the cells are now grayed out corresponding to the time of use periods that we've selected. Each hour of the day should fall into one time of use period, and there should be no overlap. If there is overlap, or if an hour does not have an assigned time of use period, an error will pop up when you leave this worksheet. And we'll repeat this process for the winter period as well for our example project. So we see up here this for the winter periods, and for our winter we only have mid-peak. We don't have mid-peak and off-peak. We don't have on-peak. So we'll go ahead and do this, holding the control key and click Set, and then it sets those hours. Now if this is confusing, remember there's a help button that explains it up here, and then a comment attached to the summer cell explaining how to do this. The electricity rate schedule can be saved similar to the gas rate schedule that we demonstrated before. Let's go to the demand worksheet now. On the demand worksheet, the first thing that you do is begin by selecting a master building schedule. This action will calculate and insert the monthly high and low temperatures from the 8760 climate zone weather file based on the scheduled hours. For our example project, the schedule is Monday through Friday, 6 a.m. to 6 p.m. So we'll go ahead and select that schedule. Next, we enter the summer and winter demand rates in dollars per kilowatt. The summer and winter periods for these rates relate to the summer and winter periods that were chosen in the electricity rate worksheet. So let's go ahead and enter in some example numbers for our project. Finally, for each month, the tool is asking you to select whether the high or low temperature should be used in the calculations for annual demand dollar savings. For example, if your building draws the most electric demand at cold outside air temperatures during the winter time, say due to electric heating, then you would select low for the winter months. So let's go ahead and do this as an example. Just for January and February, you would select low. The building for our example project is heated with gas, and so we'll select the highest temperature for each month. It's common for commercial buildings in California that don't use electric heat to draw the highest electric demand at the hottest temperatures in all months due to the load on the electric cooling systems. To determine whether buildings draw more demand at high or low outside air temperatures for each month, you can look at historic utility interval meter data and compare that to historic outside air temperature data.